Thank you for coming out to see us give our talk about Arcadia here at Clojure West. I'm Ramsey Nasser, and deep in code beneath me is collaborator Tim's Gardner. And we've been working for a while to build this framework that enables developing serious high-level video games in Clojure. And what we've done, the sort of elevator pitch of Arcadia is it's the integration of the Clojure programming language into the Unity game engine. So a quick show of hands, who here is familiar with Unity? Oh, wow, great. It's a whole part of my talk just skipped. And if you're not familiar with Clojure, then the last 2 days must have been really confusing, so I'm not even going to get into that. So this is the part I'll shoot through. Unity is a production industry standard video game engine. It's used with everything from high school students, which I teach high schoolers how to make games in Unity, all the way up to AAA, very serious studios are actually making games. And other interactive software artifacts really is the most general thing that you can use to describe it. What it gives you is a very solid graphics pipeline, physics engine, networking to do multiplayer stuff, a really well-reasoned entity component system, which we'll get into, and Tim's will talk a lot about, and a full visual authoring environment. What we're really excited about, in addition to that, is that it exports to an incredible array of platforms: desktop, iOS, Android, consoles, PlayStation 4, Xbox, and this is the real thing. Currently, Arcadia exports cleanly to desktop, and we're patching the compiler to support exporting to other targets. We get a lot of questions about how it was done, and it's really kind of fun to hear people's theories about how we did it. A lot of people think it's some kind of Clojure script hack that transpiles to Unity's JavaScript, and it's not that. It's like better and worse actually than that. Who's familiar with the CLR version of Clojure? Less than Unity, which is interesting at a Clojure conference. So there is a version of Clojure that targets the common language runtime, which is Microsoft's runtime that powers C#. It is heroically developed and maintained by this man, David Miller, who we've never met, but in order to make Arcadia work, we've had to fork the compiler. And the conversations that we've had with David Miller have been really enlightening and have made Arcadia and Clojure CLR even better just by working together. A sort of run-through of Arcadia itself before I dive into code. The framework is meant to be low-level. It's sort of we have a lot of ideas about really cool ways to make games, but that's not what Arcadia is. Arcadia is meant to just sort of wrangle Unity, get all of its weird, stateful, sometimes insane API out of the way. Their Perlin noise implementation always returns a constant number unless you add 0.5 to one of your parameters. It's like stuff like that. It's our job to sort of pave over that. But other than that, we're really not imposing any additional semantics or workflows. So it's very, very open. Anything else we sort of want to be made available as libraries. That's our sort of vision for Arcadia, is that the core be this small little thing, and then there's this ecosystem of libraries that you can use. So a summary of what the process has been like, this is the closest to a logo that we have so far. It works, you just kind of keep going at it, and it gets in there eventually. So I won't get into the internals, but before I dive into my own stuff, I want to share some things that members of the Arcadia community have been making, which is crazy. The first commit was April 17, 2014, so Arcadia just turned a year old, and we're very, very excited about that. And in the year since, there is a small, very brave community of people that are willing to use this tool. Here are a couple of the games that have come out of that world. So this is it's been called a feminist shoot 'em up, where you're this badass scientist flying through the sky, and these evil aliens show up, and you zap them with your eyes. It's great. We don't ask questions. That's wonderful. This is this is a really interesting sort of non-gamey game piece, which Unity gets used for a lot. This is a piece that reads, I believe, it reads books from Project Gutenberg and then creates actual 3D books that just drop onto the table in front of you. And you can like pick them up and read them. So this is using, it's great, right? It's great. The great thing about virtual reality is we can recreate this reality. But it's awesome when you see it animated, like the book pops up and it opens, and it's super cool. This is some of our favorite work is by a man named Joseph Parker, who, I mean, I'm just gonna play it. So this is Joseph Parker recently live streamed a 48-hour game jam over the last weekend of him making an evening of modern dance, I believe was the name of the game. And it's this completely bizarre, completely wacky, just surreal dancing game where I think in the instructions it says if the physics freak out, then you need to practice dancing more. So this is some more. There was a lobster at one point. And this is very much his aesthetic. He's very into like wiggly, weird things, and it's great. This is more of the lobster. He tweeted the Clojure code that did that, and I think it's parent bang lobster child arm or something, and it's just. Right. And this is another thing he made that he live streamed, this shooter where you have to sort of you have to plant your own bullets, I think was what he wanted. And so you're like planting turnips and throwing them at. And this is a sperm whale game that he worked on a little while ago. So this is really exciting for us because people, very much because of the sort of stability and robustness of Clojure itself, people are already picking up Arcadia, braving through the sometimes nonsensical compiler errors, and making stuff in it, and making stuff that you really couldn't make or couldn't make with this kind of ease and fluidity in another framework. And that brings me to my own work. This is a game that I recently made that was shown at Indiecade. It's called Wizard's Hands. Unfortunately, the full name was Wizard's Hands Don't Touch, because there was like this whole story, but then like people weren't touching the game. Like, oh God, what? No. Don't ever call your game Don't Touch. People won't touch it. But so this is the biggest Arcadia project that I've worked on. My collaborator Kaho Abe built this custom glove controller, which you wear and it lights up to indicate how much mana you have. There's a leap motion embedded in the palm, reading your other hand. So you're like casting spells at ghosts as they're attacking you. And what Clojure and Arcadia are doing is they're talking to the hardware using a binary protocol over serial. We're doing gesture detection in Clojure. It's all happening in an agent on a separate thread, so we don't slow down the game. It's just the full real thing. And it was such a blast to write and really easy to debug when things went wrong. And this is where we run out of slides and we dive into code, which is why that emoji is up there. So the demo, we have two demos for you guys today. I want to demo the sort of functional game development process that I arrived at in my most recent game that I've been developing.
We have one demo.
We have one demo?
My operating system just died.
So. There you go. so we have one. Yeah. We have one demo, and apparently when you patch compilers, shooting from the hips, stuff happens. So I'm going to share with you my workflow. Because of how low level Arcadia is, a lot of people use it in a lot of different ways, which we think is its strength. I'll take you through how to make a simple game in Arcadia. So who here has made a game before or worked on a game? Anybody? A couple of people? All right. So we've said this before in other talks. Making a game is like the hardest thing in the world to make. Brandon Bloom, who spoke a little earlier, says that making a game is like solving every difficult problem in computer science 60 times a second, and that's completely true. So the display is a little bit constrained, but I think we can make do. Okay, let me get rid of all the nice code that I prepared and start blank. So for those of you who aren't familiar, this is Unity. Unity is a full game authoring environment. You have the sort of scene view. This is where you could move things around and sort of set up your world. You have the game view, which is what your actual game will look like to your players. Your hierarchy is a list of all the objects in your game. Unity implements what's known as the entity component system, which is this approach to game development where every object in your game is just a container for components, and components actually implement state and behavior. And that makes it very amenable to persistent data serialization. And Tim's has built an incredible library for that. We can convert between Unity scene graph objects and Clojure persistent data pretty seamlessly, and getting more and more seamless as we develop it. Below is the project. This is the list of all the files in your project. This is where you manage textures and scripts and stuff. Arcadia is just a folder that you add. One demo that we considered doing was this neat thing you could do where you could drop Arcadia into an existing game, use the REPL, use whatever sort of Lisp power you need to fix the stateful C# mess, and then pull it out, and no one knows, and no one is none the wiser. So Arcadia is not an all or nothing proposition. It's designed to interact with Unity's existing practices and C# very, very seamlessly. And on the right is the inspector, which is information about the currently selected object. So I'm going to try and make a game in front of you guys using sort of the little bits of snippets little bits of code that I prepared a little earlier. It's going to be a 2D game, so I'm going to switch into 2D view. Can everybody see what I'm doing okay? Yeah, great. So in my 2D game, it's going to be a game about, it's going to be a ship. So I just created a ship. So again, all objects are kind of the same. So the only thing that makes this thing look like a ship is attaching the sprite renderer and the ship sprite. And now you see this guy down here. So here's my ship. And I'm going to add an asteroid. So you'll end up moving a lot between writing code and doing this kind of visual stuff when making a game. Size it so everything looks nice. Unity 5 has this like really fancy like horizon by default. It's like, guys, it's fine. It's cool. Like, just give me black. So these are my initial assets, my initial game objects. My little ship and my little asteroid. So the next thing I will add, I'll do that later. So to start building this game out, can everybody read my code on the right? Is that legible in the back? Good? Cool. So as Clojure programmers, we know that the best thing in the world is data, right? It should just be data. And when it's data, you could reason about it. So to talk about the player, let's create some data. So the player's ship is initially, let's say its position is at vector 2, 0. So I'll jump into this namespace. Here, and so this is Sublime Text. I haven't made the jump to Emacs, probably never will. Please don't chase me out of Clojure West. So what does a ship in a kind of asteroid-style game do? It does a bunch of things, one of which is it can move. So to move, we will take an object and update its position with vector2 addition of some offset. So now I can move the ship by 3 in x and 1 in y. And you see that down here. The position at the end of it is 3 and 1. So what you'll see a lot of in this talk is the arrow macro, which I fell in love with when I came to Clojure. Because I'm really into stack and concatenative languages. And it's like, oh, this is you get these mini little concatenative DSLs that you just string together. But this is sort of the backbone of a lot of my work. Because what I want to get to is Arcadia is, this is a point that I want to make while showing the slides. Arcadia is, to us, more than the sort of technical athleticism of getting a sort of fringe programming language or non-mainstream programming language running in a game engine that it wasn't designed for. It solves very real problems of game development. And the real problem, the main one being that it's very easy to paint yourself into corners while making a game. You sort of design, you'll be prototyping things, you'll be changing things, trying things out, and then you'll get to a point where you actually want to go back on a bunch of stuff that you did. But if everything is stateful and tangled together, it becomes very hard to add new features down the line. So this demo is sort of heading towards being able to fluidly add and iterate on features of your game. So this is our movement. Now, to get it to show up in Unity, you need what's called a component. Like I said really quickly, the entity component system means all objects in Unity are sort of the same. They're just containers for these components. And Arcadia lets you write components in pure Clojure. So our ship component has a state, and it starts by setting its state to the ship's initial state. So if I save that and I jump into Unity, it compiles. In order for Unity to really see any of our stuff, we have to AOT. So Arcadia is constantly AOTing your stuff so that Unity can see it. And the balance between compiled and stuff that you just sort of have floating around in memory is an interesting one in Arcadia. So I'm just going to hit play, which is how a lot of people actually use Arcadia. They just leave it playing. We'll give it a sec. Come on. Single-threaded. OK, so this is my ship object. And I'm going to add the I'm going to oh no. You guys get to see the wonderful state of our compiler machinery. Let's see. Some people ask us if we do this for a living. We don't. Let's see. All right. So it's now compiling all of Arcadia and all of Clojure. And hopefully that will have swept the dust away. Come on. OK. Player ship. There we go. Play. So a lot of the complexity comes from the fact that Unity is actually not written in C#, it's written in C++, and just uses mono as a scripting layer, and is more than willing to violate any kind of assumptions that you can make about your VM. This is sort of like, it's kind of like if you were working on the JVM and there was a daemon below that was willing to sort of poke holes into your assumptions from above. So a lot of our work has been finding where those are and just patching them up. And you just saw a daemon finger come through Arcadia. That's what that was. But so this is a pretty recent feature. So we have player ship. Def component is basically a def type just made to play nice with Unity. And you'll see that state, the persistent data actually shows up in the Unity inspector. And you could like modify it and play with it if you want to. It's basically set banging every time you update it. And this becomes a really nice way to visualize persistent data as it's moving through your game. So right now the player ship is not doing anything. And you'll see that changing the position doesn't actually move the player. Because what moves the player in Unity is this component. The transform component is what determines where an object is drawn. So the way Unity expects to be used is to have components talk to each other. So we need our player ship component to reach over to the transform component and tell it to move. And the way I like to do this is this. So I'm going to define update player object. And we put this in a little pipe, and we say, so we're going to pass this in. We're going to pass the player state in, and we can move the player. Before we moved it by a fixed amount, but actually to make it interactive, input get axis horizontal. So get axis, these are Unity API functions. The horizontal axis is basically -1 when I'm pressing left and 1 when I'm pressing right. The vertical axis is 1 when I'm pressing up and -1 when I'm pressing down. And Unity smooths between the two. It's quite nice. So that, now if we add an update, set bang state, update player, update player. Why do I call that player? Let's call this ship. Update ship. State. So this is the sort of, this is what I arrived at and was really excited about and worked very, very effectively. You can sort of start to build these chains of non-side affecting functions that build up and modify persistent data, and then in one place update the actual data for a player one place during a frame. And then after that, you'd like update graphics and do whatever it is that you need to do. But you have this very clear separation of the abstract notion of what you're doing in a frame and then telling Unity how to reflect it visually. So let's save that. Compiling. What's that? Oh yeah, I mean, do you want me to like stand off to you, or what do you want? Okay, yeah. And now, does everybody see the Y value going up a bit? So I'm pressing the up key on my keyboard. You can't see that, but you have to take my word for it. So that's the bridge. That's Unity's input system coming in our not pure but non-side affecting function, updating the map, and the map itself is being sort of swapped out with the map that we have set as the state of the player ship. So the object is still not moving because all we're doing is just updating data. To actually reflect the change, so you update the position to the position in your state. Right, that should do it. So that compile. Except that your position is two-dimensional. So let's actually do this. So I'm actually I'm going to destructure. No, I'm not. So it actually needs to be a three-dimensional position because Unity is three-dimensional. And And then the z is, right. Right, and z is 0. That should do it. Okay. Let's pop back in. These are the sort of wait and compile and beach ball is the normal live coding experience in Unity, and the REPL tends to beat that. And let's see if we can actually see how this ship. There we go. Woo! Video games. So, so I actually want to walk through that manually in front of you guys because that's the this is Arcadia out of the box. So for the game that I built, I actually ended up building a bunch of macros and functions that would start to just fold in patterns that kept coming up in the development. The end result was super easy to sort of tweak. I want to show you a more sort of complete version of what that looks like, and then I could walk you through the code so you don't. Okay. So this is the full sort of game. I'll get rid of the stuff that I wrote here, and I'll bring in this ship, and I'll bring in the asteroid logic. Right. Let's bring this in. So this should be okay, unless I have my order messed up. Where's my? There you go. Okay. So I will walk you through this code because it's being a little buggy, and maybe clean it up a little while Tim talks. But basically, the exciting thing is that we're able to. This is the logic for the asteroid. You see that you could start to build these pipelines, right? And when doing game development, what this code started off as originally kind of looked like that. The asteroid starts at an initial position, but then you can give it a random speed initially, right? Or maybe take out the random speed. You can give it a random special movement. And the special movement, again, is just data stored in the special map. And the way the specials get done is they get folded back into this asteroid update function. So this is a lot like what I had for the ship, except because it's a pipeline, you can just start adding other things as you want. And this just works. You just end up writing functions that pipe maps and operate on maps. And at the last step, you sort of update the Unity component. And all Unity knows is it just got handed this data and told to move things around on the screen. And it leaves the sort of flexibility of modeling your game logic in this non-side affecting world. But you're still able to performantly talk to Unity and have it update the scene graph as you need. So those are the sort of bits and pieces, working and otherwise, of my demo. And Tim has some stuff to tell you guys about serialization. Do you want to plug in? Or?
Yeah, I'll plug in quickly. Somewhere in the unholy mess that is the most recent Oculus dev kit, Siphon, which is something that hacks the Macintosh GPU, Unity 5, and the latest release of Arcadia, Unity got into that state. So this is going to be a little bit more descriptive than demonstrative. But here we go. So I'm going to talk some about upcoming features in Arcadia and things we're working on, and especially with a focus on the hydrate library, which is intended to throw as much of the logic in putting a game together into persistent data structures as possible. And by extension, all of the functions we usually use to manipulate Clojure data can be used to manipulate games. So this is a movie from a job I did for a group called Sonic Platforms in New York. I just threw this together pretty quickly over weekends. These are scans we made during a party of people using a little scanner thing on an iPad. The background here is generated using the hydrate namespace in Arcadia. And I can show you the code that made it. And this keeps going on forever in the background there. So these procedurally generated blocks, rectangles, whatever, keep coming. For me, the interesting thing about that is, and so this is a map that we're putting together. Here's the children. It's a large function. It was made in anger, but a point to look at is that this is in fact the entire code required to make this, which I think is relatively terse. This map structure maps directly into the Unity scene graph, and then just becomes that. And for me, the most exciting part of this is that the code to generate the original structures that you're seeing here, this original mess of rectangles, can then be used to, after you make these things and put them in the scene graph, you can use those same maps and the same functions that generate those maps to repopulate the existing objects in the scene graph. So you don't have to pay for instantiating them again. So paying for objects instantiation is rather expensive in Unity. And that means that you can just keep cycling them infinitely, though there's just a finite number of these rectangles that are actually existing, a couple of hundred. But they can just keep coming, and again, all of that's contained in this screen you're seeing here.
Yeah, so if you saw like the transform component in my inspector, that transform key in the map on line 24, that maps directly to that component. And then the local rotation and local position keys, they map directly to those fields.
So just quickly, in like the 3 minutes of time we seem to have, for the next release, we have several things planned, obviously more stable Arcadia and much better documented than what we've had so far. We're closing in on having everything nicely tied up. We want web export, which is something that the Unity 5 makes much more feasible for us. We want to work on other export targets, and that's web export to HTML5, so you can just play it in Chrome or whatever without having to download anything. For Hydrate, the system that I have in mind is one using, I don't know if anybody's aware of Brandon Bloom's dispatch map library, but it's a localized multi-method system. So you can extend the polymorphism of some function without mutating a global state. And this means that different people can both define functions on a third-party class without conflicting with each other, which seems like the correct way to do something like Hydrate, the entire point of which is that you can convert arbitrary classes, arbitrary objects of any sort, into pure Clojure data. So we're going to set that up, make the optimizing macro, which generates all of the hydration grammar, much more accessible and high-level, and then release as soon as we can.
Cool.
Yeah.
So
do we have time for questions?
Yeah, we'll take questions if there are any. But
2 minutes.
That's all we have. Yeah. Yes.
Cocos 2DX. Any playing around with Cocos 2DX at all?
So Arcadia is Unity specific, and it's baked in. It's how we make this perform as it is. So it wouldn't have been Arcadia. I have played around with OpenTK, which is a C# idiomatic wrapper over OpenGL, and I'm using the sort of work we've done in Arcadia to target that, but I haven't played with Cocos.
Do you have any advice for library authors who would want to make their libraries available for CLR specifically Unity?
Yeah, it's an interesting.
So the question was, do we have any advice for people who would like to write libraries for Arcadia? For the CLI use? Yeah.
Right. Yeah, I mean, feature expressions is the sort of the answer.
Right. Well, we should also say that we're working on a package manager. So that's going to use Clojures and Maven. I mean, it's a Maven-based thing, but we want to have the same push-pull stuff that you expect from Lightning Gen, for example. Which for various reasons we can't directly. Well, we can't. It's suboptimal because we need. We basically don't want to be coupled to the JVM for it, but we still want to use Maven.
So feature expressions is the sort of best difference, but I think as the CLR version of Clojure gets used more and more, that's the sort of dual nature of Clojure, of like Clojure and Clojure script is going to become a really three, like a triangle.
Any other questions?
How far is the CLR compiler you all have now versus the sort of general real one? You know what I'm saying?
Yeah.
I think we're on 1.7.
1.7.
Okay.
Yeah.
But like, how are you all running on the vanilla CLR Clojure runtime now? Because originally you had your own version, right?
This is still our fork.
Okay.
But our fork isn't doing anything. Does not deviate from the stock in any way.
Okay.
Yeah, and we're sort of an R&D branch of Clojure CLR at this point, so we're pushing because we're using it maybe more intensively than a lot of other people. So and so with more intensive performance demands. So we're pushing to the mainstream.
Cool. Our ideal workflow is to stress test in Arcadia and then push out to the mainline, which we've done. We've done it in good patches.
So there's like a goal eventually that they'll just be a unified platform, sort of.
I mean, so Unity actually violates like the basic assumptions of Mono in terms of like file structure. So that can almost never be the case, but that would be the idea.
Yeah, and I mean, it's also interesting because there's some things that the CLR affords you, which the JVM doesn't. Like they have support for true generics, which means that potentially you could get rid of all of the boxing and unboxing stuff that we have to put up with. And just things like that. They have extensible value types, lots of fun things in there.
Yeah, do you think the open sourcing of the CLR will affect your development in a good way?
So the question was, would the open sourcing of the CLR affect our development? That sort of depends on Unity. So Unity has its own proprietary branch of Mono, and the the direct. I mean, so one way it could is if more people start using Clojure CLR, that'd be great. But it's up to Mono whether we can directly partake of that.
Unity is not likely to switch off their version of Mono anytime soon, but for the greater Clojure CLR ecosystem, it's extremely exciting. If that's it.